Hello everyone, this is Yunxi Li here. I'm going to present an introduction of a research project on air quality changes before and after the new cycleway opening to help reduce traffic congestion as part of Engine 769 research methods for engineer assignment 5 submission. My email address is stated in this slide, and my lecturer for this course is Wan and Kimi. So in this presentation, I'm gonna talk about introduction. One, the introduction, the research project introduction, which broadly describe research questions. Two, methodology used for data collection and predict that and also analyzing test methods. Results. Three, few tables graph showing in this section to assist with results. Four, discussion on the data results, on the data analyzing results. Cool. Firstly, we're going to talk about introduction. So a bit background about it. As a result of modern urbanization, there are more and more vehicles on urban roads, causing congestion and air pollution. Therefore, cycleways and public transport are bringing more and more attention on reducing traffic congestion and air pollution. There was a cycleway constructed in May 2018 with the aim of provide more travel solutions to reduce traffic congestion problem. We have had this opportunity to be involved in cycleway project as an early stage to demonstrate whether there is any pollution improvement as a result of opening of the cycleway. So now we move on to methodology. On this methodology section, firstly we're gonna is data collecting. So collecting before data and predict data and collect after opening data and predict when data. Then we're gonna create a time series over the total of 6 week period. Fourth, we're gonna run RMSE, MAE, and correlation coefficient to test the performance of our model. And then compare the before and after opening observed statistics data. At the last, we're gonna run independent sample t-test to validate whether the cycle open of the cycleway is improving the air pollution step or not. Okay, data table. Firstly, this is data table. On the left table, marked gray is observed NO2 data, and on the right, observed and predicted data before the opening of the cycleway. On the right is the observed and predict data after the cycleway is opened. This is the time series we have created. So there is total of 6 week period, with 3 week before the second way opening, and 3 week after the second way opening. Then we have run RMSE and MAE tests, which you can see at the bottom of the table on your left is MAE and RMSE number. On your right is correlation and coefficient graph, which the correlation coefficient between the observed and predict daily average NO2 levels. This graph observed versus shows observed versus predict concentration for the first 3 weeks of data, which showing the data is performing well. And then we move on to statistics table. So on the left is before opening table, and on the right is after opening table. From this table, we can say the mean value of the NO2 level is reduced from 8.12 and milligram per cube, dropped to 4.5, and median value before opening is 8.13, which versus after opening median value 4.553. So the total NO2 concentration over the 3 week before opening is 170.57, and after opening 3 weeks is total of 94.43. And now we're going to talk about the results of our t-test. Our t-test t-value was calculated. T-value calculated is 3.675. P-value calculated is less than 0.01. The t-value is larger than critical value of 2.021. The p-value is less than 0.05. The 90% confidence interval does not cross zero, because we can see on the table the 90% coefficient interval is lower at 1.6, upper at 1.5, which is not cross zero. So therefore the observed NO2 concentration is statistically sufficient. Which brought to the end of my presentation. Thank you for your time, and if you have any questions, please do not hesitate to contact me on my email, which is at below of this slide. And thanks again for Bart, Barban, and Kim.